Okay, let's dive straight into one of the most beautiful and, honestly, conceptually fascinating ideas in all of machine learning. Welcome to this explainer. Today we're going to unpack exactly how computers make some of their most reliable decisions.
Section 1. The beautiful idea.
To solve massive problems, we really have to shift our trust away from a brilliant loner and toward a collective group. As this quote beautifully captures, a single decision maker can be unreliable, but 1,000 slightly different decision makers voting together become remarkably wise. And that right there is the exact leap required to move from a single decision tree to what we call a random forest.
Section 2. The decision tree.
Let's start with the baseline. A decision tree is loved for its transparency, mostly because it thinks exactly like a human playing a game of 20 questions. It's a super intuitive model that uses a simple flowchart of yes or no questions, sequentially filtering data until it reaches a firm decision right at the bottom. So absolutely no black box mystery here.
And this perfectly illustrates that real-world logic. Is their income above $50,000? Yes. Credit score above 650? Yes. Is their debt manageable? Yes. That string of affirmative checks leads straight to an approved loan. It's incredibly easy to follow.
But here's the catch. A single tree is actually incredibly fragile. If it grows too deep, it tends to overfit, meaning it memorizes random data quirks instead of extracting the real patterns. Change the underlying data just a fraction, and the entire tree completely reshapes itself. Ultimately, you're left with an unstable, highly opinionated expert, and we don't want that.
Which brings us to Section 3, Growing the Forest.
So, here is how we build something far more powerful. Instead of putting all our faith in that one fragile, opinionated tree, we deliberately grow a massive forest. We're talking hundreds or even thousands of different trees built to tackle the exact same problem. But here is the magnificent twist: deliberate imperfection. We actually force these trees to be slightly different from one another by giving them random data samples and only a random subset of features to look at. Basically, we ensure no two trees see the exact same picture. And the result? Each one is its own imperfect expert that is wrong in its own completely unique way.
Section 4. The wisdom of crowds.
Once we have all our beautifully flawed experts lined up, we rely on the ultimate equalizer, the vote. The rules here are incredibly straightforward. For a category, like deciding if an email is spam or not spam, you simply take the majority vote from the forest. And if you're predicting a number, well, you just average all their answers together.
And when they vote, something truly magical happens. Their individual, independent mistakes entirely cancel each other out. Because their errors are completely random, they just fade away right into the background, leaving only the stable, highly accurate, genuine signal to reinforce itself.
This algorithm, the random forest, is quite literally the wisdom of crowds turned into code. It stands today as one of the most reliable tools out there, powering heavy-hitting real-world systems like credit card fraud detection, complex medical predictions, and even the recommendation systems that tell you what movie to stream next.
So as you look at how AI makes its most crucial decisions today, I want you to keep this simple rule in mind. Why bet everything on one fragile expert when you can ask 1,000 slightly different ones and let them vote? It really begs the question, if deliberate imperfection makes machines this smart, how could this change the way we structure our own human organizations? Thanks for joining this explainer. I hope it helps you see the forest for the trees.